Hi, everyone. Good morning. This is Tiffany. And as our convention, let's wait for the other guys for a couple minutes, and then we will start at 11:05. Oh, maybe it's 10:05. I'm in Eastern Coast, so I don't really. Yeah, okay. It's 1 p.m. now, so it's 10 a.m. Sorry. So let's start with 10:05. So it's like 3 minutes later. All right, guys, let's start. Can you guys hear me? Okay, cool. Awesome. So guys, first announcement. As you may already seen, the third assignment is released. So you should be able to get the information regarding assignment 3 in the course website and then schedule, and then you'll be able to see the link for assignment 3. And assignment 3 is composed of 2 waves. The first wave is about Stack Overflow, and then the second wave is about format string. So for the Stack Overflow vulnerabilities, they're already on. You will be able to play it right now. And you will see that there are 20 levels. Each level has 1 teaching challenge and 2 testing challenges. And then later on for the format string wave, it will compose about 7 challenges. And it will has also teaching and testing challenges, although it's going to be 1 teaching and 1 testing instead of 1 teaching and 2 testing. So in this assignment, you don't have to finish all the teaching challenges because we're not going to score for your teaching challenges. We only score for your testing challenges. However, for those testing challenges that you don't know what to do, I really, really encourage you to test or to play with the teaching challenge first, because the teaching challenge, they will give you very nice information. They will give you guidance for how to look at this challenge and what you need to pay attention in order to achieve this challenge. So yeah, so make sure that you go over teaching challenge if you don't know how to handle testing challenge. But if you do know how to handle testing challenge, feel free to go ahead and just play on testing challenge directly. So the deadline for assignment 3 is gonna be the end of October. I hope that in this way you will have enough time to play with it. However, I know that you already played reverse engineering challenges, so I believe that you're already quite experienced in how to accomplish the assignment. So I will just recommend you start early, because this challenge, those challenges are actually, I would say it's harder than the first reverse engineer one. So you definitely want to start early. If you only spent, say, 3 days to finish the entire, unless you are super familiar with Stack Overflow and format string. Otherwise, it's gonna really, you can't not finish it in 3 days. Like for me, if I'm gonna play those challenges, I probably need a whole day to finish all of them. So make sure that you do allocate a decent amount of the time for this month's homework. Okay, and the other thing that I would like to head up to point out to you guys is that next week we're not going to talk about anything about new technique stuff in terms of hacking. However, we will talk about new stuff about binary analysis. So we are doing manual analysis, we are doing manual hacking, but we don't have so many people working on binary analysis or security challenges every day. So we have to make it automated. And there are a bunch of researchers looking into this problem. They're thinking about how to make binary analysis, or say how to make bug finding automatically so that machine can find it by themselves instead of we have to manually look into that. So this is like a very broad research area. I am in this area. Many of the PhD students who's in this class, they're in this area, and many professors, they're also in this area. So next week, we're gonna have a guest lecture. We're gonna have one of our SEFCOM folks. He's gonna introduce binary analysis, fundamental binary analysis to you. And I hope that you'll stay here and enjoy the lecture. I think it will be really, really helpful to have it's gonna really, I would say mind blowing. It's really gonna be eye opening for you to touch a little bit about automatic binary analysis. And also, I would like to have you think about binary analysis, like automatic binary analysis by yourself. And hopefully, this is gonna be a good teaser for you to start. Also, I hope that if you're interested in this kind of a research, you are welcome to contact me or contact SEFCOM folks, and then you can play with us and look into this world of automatic binary analysis. Okay, so that's pretty much it for today's prologue. And now let's start to roll again today's lab. So today's in-class lab is about format stream vulnerabilities. The service has been on, and you should be able to connect to the service using Netcat, the same link, the same URL, and then the port is going to be 7777. And you will be able to get the binary from the specific link, or you can just go to the course schedule and you will be able to see the binary over there. All right, similar to what we have done before, let's have a couple of minutes working on this by yourself. And later on, I will start to talk about this specific challenge. And I copy paste the link to the chat. So you can go to the Zoom chat and click, and you'll be able to get the binary. How's it going, folks? Are we able to connect to the service? And also, can you are able to open the binary and analyze it? Good. Awesome. Thanks for letting me know on chat. I know that some of you are trying it because I can see every connection that you guys make. So I know that you're making progress. So I will give you more minutes to try since the exploit is pretty simple in terms of, like the lines of a code. I think for me, my exploit is only one line will be able to exploit this correctly. So I'm going to give you a couple more minutes so that you can try it by yourself. Let's say 15 minutes, actually. I think what a half an hour will be sufficient for me to explain the exploit. So you'll have 15 minutes to go. And after 15 minutes, I will start to talk about this challenge. All right, guys, it's 10:50. Sorry, 10:45 now. And let's start to analyze this binary and play with this challenge together. So first of all, let me share my screen with you. And then let me zoom in more. Okay. Can you see the screen? Cool, thank you. So, as always, when we have this binary, so in my folder, the binary is format string over here. So first of all, let's check the format. As you already know, this is ELF64-bit, right? And then the next, what I usually do is that I will use checksec to see, what this binary, what kind of a security mechanism has been enforced in this binary. So we found that actually canary is enabled. And then NX, which is non-executable stack, is also enabled. But then PIE is not enabled, right? So that means that every time a function is loaded, the address of the function is going to be fixed. And also this is like partial relocatable. Okay. So this stack NX enabled is the key information for us. So we know that we cannot execute stack anymore. So we cannot insert shell code. And then also there is a canary. So we know that we need to bypass canary check, making sure that the canary will not be affected, or we need to find a way to leak the value of canary. Okay, so now let's use Ghidra and analyze this binary. Reverse engineering it. I already opened Ghidra, and it's right over here. And right now I am in function main. I already disassemble it, show it in the right-hand side panel. Can someone tell me, like, this binary, do you have a coarse idea of what is this binary doing and what possible vulnerabilities does this binary have? You can either talk or you can just type it in chat. No one has an idea? Or no one wants to talk? All right, I see your guys typing in chat. Yes, format string vulnerability, and then puts like we talk about. Well, not quite, because here, if you look at puts, it just puts something, it just prints something. There's nothing that you can control, right? Because this string associated with puts is not something that input can control, right? And yes, so the vulnerability happens right over here, printf, because v1, if you look at the string, you will be able to find that v1 coming from, where is it? Here. So there is a read statement. So the read function reads a string from standard in. 0 is standard in. If you're familiar with read function, the first argument is the file descriptor that this function reads from. And then the second one is the argument of, the argument of the buffer that this read will write to. And then the third is the length of the reading bytes. So here, if you look at V1 is map set with, oh, it's over here. It's map set with 400 hex. And then when we read, it reads for 300 hex. So there's no way for us to overflow V1. So in that way, we know that there's no buffer overflow for V1. However, if you look at printf with V1, so V1 is something that controlled by input, right? So it's like we print something, and then this program is gonna take that as an input and digest it. So V1 is something that's controllable by us as the client, or say as the user, or say as the attacker. And then printf is going to use that directly. So there is a format string vulnerability. And as Devin said, yes, we can control the value of V1. Okay, so now we know that we can control the V1, the variable V1, and there is a format string. The next step is that how are we going to take advantage of this? So do you guys have any clue of how you can take advantage of this vulnerability? So I wonder if you find function win in the binary. Yes, I saw Linkphone writing in the chat. We can redirect that to win, exactly. Yes, and Bendon mentioned that we can use %n to change RIP in, well, that's an interesting idea. So I think %n is correct. And then how to change RIP to change the saved RIP in RSP? That's a question. So think about this. We want to redirect to win, but then for the save, there are two ways that we can redirect to win. One is to change the saved RIP in stack, right? And then another way is to change that to rewrite a known function inside this particular binary and change that to win. So the next time when this function is called, the program may thought that this function going to say memset or a, but actually it goes to win. So let's think about the first one, like overwrite the saved RIP and then replace that with function win. So if that is the case, then and if we want to take advantage of format string vulnerability, we have to know the address. By the way, guys, I just got a message saying that my internet is unstable. So if you didn't hear me, please let me know. I will repeat. Okay, so let me continue. As I mentioned, so right now we are thinking about how to overwrite the saved returned address on stack. Turns out that it's going to be hard for format string vulnerability. And this is because for format string vulnerability, you have to know the address that you write to, right? If you remember this. Hey guys, I was disconnected. I dropped. And give me a second. Let me reset up everything. And thanks, James. Yes, welcome back. All right, give me a second. I'm sorry, guys. All right, everything seems to be back to normal. Let's continue. So where I'm at, oh, okay. So last time I was talking about, so here, it's gonna be hard for us if we're gonna overwrite the return value saved in the stack. And that is because format string needs a specific address to write to. If you remember what I'm talking about in the, in the video, and I mentioned that, format string can do arbitrary read or arbitrary write. And then for arbitrary write, you have to know where you want to write to. But in this case, you don't know where the stack is going to point to. You don't know the stack's address, right? So we need to change our idea. We're not going to overwrite the saved return value on stack. And the new idea is that we're going to overwrite a value for those functions. So let's say we're going to overwrite memset. In this case, since there's a loop, so if we use printf to overwrite the value of memset and then point it to the winning function, then next time when this loop continue, the program will execute memset again, and then memset will actually go to the win function and then do what we're doing, like what we want it to do. Okay, so at this point, do you have any question? No? Okay, nice. So I suppose that everyone is very clear about our goal right now, which is to overwrite function memset with function win. And by the way, it doesn't have to be memset. You can overwrite that with other, like you can use puts or you can use read. It also works. It just like right now, I just use memset. I just randomly pick one from this three. Actually, you can use stir as well. Okay, so now we need to figure it out. Where is the function pointer for memset? If you remember the first video in the class, in the the YouTube videos, so I talk about dynamic link libraries, and I talk about those functions coming from dynamic linked libraries. I talk about the global offset table. So interestingly, memset is coming from libc. So memset is stored in the global offset table, the function pointer of memset. And then let's take a look together. Okay, so now I am going to, first of all, clear this up because I am very OCD on this. And then let me do, let me think about this. How should I start? So let's do format string to do a GDB first. Well, actually, let's just disassemble it first. Option down, because I want to chat the D format string, because I want to chat the PLT. Section PLT, which is like the temp line that you will be able to jump to the actual function pointer, actual start of the function. So here, this is the section .plt, and then memset is right over here, right? And then it will jump through this specific statement, and then this is the global offset table that's gonna store the function pointer for memset. And then let's dynamically run this and figure out what's happening. And you should be able to familiar with this if you already watched the video of memset. Okay, it's right over here, right? Okay, so let's do GDB format string. And then let's just do a break main and then run. Okay, where are we now? Okay, at this point, we're about to execute memset. And then now let's take a look at the address over here, which is this guy. All right, so this is the current value that is stored in the global offset table, and then points to 776, which is the next one. And then if you're familiar with it, you know that this is actually the preparation process to resolve this particular symbol. So let's just do next again. That means that we're gonna finish memset statement, and then let's take a look at the global offset table that stores memset again. So this time, we found that this changes, right? And then let's go to this place. Let's just print a couple of instructions. Ooh, we need to make it a hex. So sorry. So there are valid instruction for map set. Okay, so now we know that this is the particular address, hex 601040. That's going to store the value for function pointer map set. And then we want to change that, right? We want to overwrite that with the value of win function. Okay, let me just record this. Let's start with an attack. I'm going to call it attack service. Okay, and then first let's just put the piece of note over here so that we won't forget. So this is the global offset entry, GOT entry for map set. And then let's find where the winning function is. So the winning function is at where is the winning function? It's right over here. Okay, it's this address, 400964. I'm really bad at memory, especially remembering those digits, so I'm going to copy paste it. So that is the winning function. Okay. And then the goal for us is to make this place. So like I am dereference it, right? So like we want to make this particular address equal to the value of 400964. And then now we can work on this together. I'm gonna first import from pawn import. We're gonna use process for now, because I want to, run this locally. And then the standard template thing, if name is equal to main. Okay, now let's start to write the program for main. So we now know the winning function. Let's just put it as an argument for 00964. And then the address is 601040, right? And then let's do P is equal to process. So it's a format string. Okay. And then let's go back to this particular function, main. Just check this again. We know that this is the problem, right? This is the vulnerability, and we need to exploit it. So we need to figure out where it is. We need to figure out the stack location of this particular argument. So if you look at here, you will be able to see that this is V1, and then Git already nicely give us this location of the variable V1. It is at this particular location. So usually, this is one way that you can find the location. You can find, where it is in terms of the, also in terms of the location for the bottom of the stack. Because remember, when we do printf, we want to use the bottom of the stack, and then it will start from the bottom of the stack as the first on stack argument, which is the 7th argument for printf, and also the 6th argument for the format string. So we need to find the location of V1 so that we can locate where we want to, the number of the argument and then the address that we want to overwrite. And one way to look at this is to do that statically. And another way is to look at that. Another way to look at that is to use GDB again. And I usually use GDB because it's just like clear for me. So I'm gonna run GDB again. And then I'm gonna break at main, run. Okay, and then you can check stack. So here is the bottom of the stack, right? And then you can check, actually, I don't know if arg will go there. Okay, there's no argument, but we can check V1. And in this case, since I am compiling it with debug symbol, you will be able to get V1 directly, right? You can also get the address of V1, which is FD8C0, which is the bottom of the stack. However, you don't have to do it. Like if you don't have debug symbol, you can still get the address of V1. And one way to do that is to stop at this particular place. And then you know that V1 is going to be the first argument. So you can just check the register of RDI to get the value of the address of V1. You can also just stop at the mem set and then check the first argument. So here in this case, we're going to just use this debug symbol and know V1 is actually the bottom of the stack, because this value, which is the bottom of the stack, is equal to the value of V1 at this point. Okay, so now we know that V1 is in the bottom of the stack, and then we're going to compose the format string. So first, we know that, suppose I'm going to use buff to show that this is the format string. And then we want to overwrite some value to a particular address. So we want to use %n, right? And after that, I know that I want to overwrite. I want to, to overwrite to a particular address, and I want to overwrite with that value. And that is a lot of value. So we want to put it before here. We want to put it before %n, so that by the time the format string is going to, parse %n, format string is already print that amount of bytes. And then followed by that, I usually just put the address that I want over, like after this %n. So I can do P64 and then the address. And the reason why I usually put the address in the end of the format string is because for x64, this address, it usually have 0 as prefix. It's not going to be occupy the entire 64 bits. So there will be some 00 by the end of this struct packed version of the address. So I want to make sure that this is in the end of the string so that it will not break the entire format string in the middle. Okay, so now we have a very basic structure for the format string. And then starting from there as the template, and then we need to refine it so that it will print exactly that what we want. So what we're going to do is that first, we need to figure out how many bytes that we're going to print at this point. And then we want to be able to make this XX, that part, fill that blank correctly so that we will have exactly number of bytes. So here, this is the function, right? And that is the number. And then let's first convert that to decimal. It's going to be 400964. So that is this number, 4196708. Okay. So I'll just put over here, 4196708. So I want to output that many bytes. And then how are we going to do that? So I can use a %, like make this part as the width specifier for the format. And then I can do this. So this means that I am going to print the first argument. and then with the width of this 419678 with those values, like those number of bytes. And I usually put a 0, means that I'm gonna pad those, this entire integer, the first argument, with a 0, so that I know that this part has been printed. Okay, so now we have this part. We know that by the time we print %n, we handle %n, we're going to have exactly that number of bytes. And then next, let's think about how to handle %n. So here, this is the address that we want to overwrite to, right? And then if you look at the stack right now, we know that buff is in the bottom of the stack. So, I mean, let me draw over here. Actually, let's see if I can clear this up. Okay, cool. I'm gonna use the left-hand side as a whiteboard for me to draw. So suppose that this is the stack and this is where RSP is pointing to. And maybe somewhere above, like this is the low address. And this is high address. So we know at the bottom of the stack is where the buff is. And we already put some values over here. So I'm gonna erase this and then put the value, which is %, and then 04 196 7 1 2 3 4 5 6 7 8. Okay, 7 0. So this is 8 bytes, and 8D % again, and so think about printf. Printf, the first 6 arguments gonna go to register, right? And then starting from the second argument, it's gonna look at the stack. So this part will be considered as the 7th argument. But then if you have a format string over here, you know that the second argument of printf is gonna be the first argument for the format string. So here's gonna be the 6th. This is the 6th argument for format string. Okay, so now we know this is the 6th argument. That after this 8 bytes is gonna be the 7th argument. And after this 8 byte again, it's gonna be the 8th argument. So far, since already occupies some of the bytes in the 7th argument, we cannot make this address at the 7th argument, but we can make it as the 8th argument. So what we're gonna do is to make this address as the 8th argument, and then fill some blank over here, like some garbage bytes, so that this 7th argument will be complete. Okay, so what are we gonna do is that first, let's fill this part first, because if we're gonna fill this, this is gonna still take some value, right? So we're gonna say this is gonna be my 8th argument that I want to print to. So I want to put 8 over here, and then I'll have that value. But then after that, let's keep filling this. So we insert 8 and $, this another 2 bytes. So here's gonna be $8, and let's count how many bytes that we have over here for the 7th argument. So that is 1, 2, 3, 4, 5, 6. Okay, so that's 6. 6 means that we probably need 2 more, but hold on. So here, if we do %n, it will only output 32 bits because it will consider that as an integer. So we want to make an L over here. So that is another format specifier, which is gonna specify the length of it. So here, the length is going to be 8 bytes if we put L over there. So now we'll have one more. So all we need is just another byte as the garbage byte. I'm going to just put A over here. All right. So now we have the entire format string. And the rest is going to be very easy. You just need to send this to the process. And then here, I'm going to just do this locally now. I'm going to do send line with this specific buff. And then I am going to receive and to the, this is the value that we know that will ask you for your ASU, right? And then we're going to interact. Interactive. Oh, and let's try this. Hopefully this will work. Let's try this. Attack service. Oh, it doesn't work because I haven't put P64 over there when I import the function from the Pwn package. Here we go. Okay, so I'm going to put Tiffany B, and then it said your ID is locked. Good. So that works. Okay, so that's pretty much it. And then all you need to do is to rename this to connect to the remote server, and you should be able to log in your participation. Okay, sorry guys, I have to be late for 2 more minutes because the network got disconnected. But if you have more questions, you are feel free to talk to me right now. I will stay here into 11:30. Or you can go to the office hour and ask TAs for questions. That's it. I'm gonna stop recording. If I can find stop recording. Here we go.